So first of all, let's try to understand why did we need physical quantities. Okay. So first of all, let's try to understand why did we need physical quantities. Okay. So from the very beginning, uh, there were various things like distance or time and everything. So we needed a standard standard procedure, okay, to measure these quantities. And what are physical quantities? So like I said, like the distance, like if we are traveling from city A to city B, like how can one person say to another person what is the total distance? So similarly the total time taken and everything. So there were the quantities, like very important. The next line is very important. There were some quantities that people observed that could be measured. Okay, there were quantities that could be measured, and not only distance or time taken or like weight or mass or everything, some properties of a material, like various experiments have been carried on since like the beginning, and like various properties of any material like resistance and everything. I hope I don't want to dive into much detail right now. So yeah, so I just want to explain that there were some quantities, all physical properties of a material, again they are quantities only, that can be measured. Okay, that can be measured. And yeah, so that's basically it. So let me write down the definition. So a physical quantity is a physical property. Okay, a physical quantity is a physical property of a material, like I said, of a material or system. Sorry, of a material or system that can be quantified. Okay, very important. That can be quantified by measurement. Like this is the crux of this definition. And this also tells why did we need something like that. So that can be quantified by measurement. Okay, so like distance is a physical quantity because it can be quantified by a measurement. Like distance between two cities can be 100 kilometers, for between any other two cities it can be 1000 kilometers, and similarly. So the distance, we can quantify it by measurement. Okay, and for measurement we need units and everything that I would discuss later. But yeah, physical quantities, like I hope you are clear with this definition. It is a physical property of a material. Yeah, and not only like distance, it can be a physical property of a material or system, like resistance, viscosity, and things like that. That can be quantified by measurement. Okay, so we can if we want to dive into the mathematical aspect of physical quantities, we can somewhat write it like this. A little hard to understand right now, but please have some patience. Okay, so what are the terms involved here? So Q is any physical quantity. Okay, this is the mathematical aspect. Okay, this is the mathematical aspect for any physical quantity. Yeah, for any general physical quantity. Let's say Q is a general physical quantity. So how can we mathematically write it down? So Q is any physical quantity, like I said. Okay, Q is any physical quantity. What is N here? Okay, so N is the numerical value. I will give examples to make it super clear. Right now, just clear it with me. So N is the numerical value, and what is U? Even more important. Like I am putting a star on U as well. U is the unit. Now, what exactly is numerical value? What exactly is unit? We are just going to study unit. I will discuss a bit later. Okay, I'm writing it here in short. A bit later, we will discuss it as well. But yeah, right now, just look at some examples. Okay, so like I said, distance is a physical quantity. So I'm writing examples here. Okay. So as distance is a physical quantity, example, like say we have 2 points or like two cities or anything, and distance between them is 10 meters. Okay. Okay, so how can we write this thing down? Like how can we write this thing down? So the distance d can be written as 10 meter. Okay, so this format, I know it's like very basic, but it will help us to solve questions and help us gain more deep conceptual understanding as well. So this d equals to 10 meter. This format is exactly same as this. Okay, q is equals to nu. Here this d represents the physical quantity, which in this case it's distance. Okay, this 10 is the numerical value. It's kind of, you can say, it tells the magnitude. Okay, and this meter, okay, here M stands for meter. Like we could have used kilometer or millimeter or anything, but this M is a unit. Okay, this M is a unit. Like how much? Like if we say, like let's say for any other 2 points, d2 is 20 meter. Okay, so the magnitude changed but the unit was same. So yeah, so I hope you are clear with this notation, and I gave an example as well. Let's take another example to understand even better. So let's say for let's say time. So let's t equals to 10 seconds. Okay, let me write it clearly. So t equals to 10 seconds. Again, this thing matches this format. Okay, because time can be measured. Like I said, please be very clear with this thing. Okay, any physical quantity, like we discussed distance, and now we are discussing time, etc. So why are distance and time physical quantities? Because they can be quantified by measurement. Okay, so like a process takes 10 seconds and another process takes 20 seconds to complete. So yeah, that time can be quantified by measurement. We can say that it takes 20 seconds, like we can quantify it by measurement. Okay, so time is a physical quantity, and because it is a physical quantity, time should also follow this format. So we can write q is equals to nu for time as well. So this is an example of that only. So here again, this t is the physical quantity. T is a physical quantity, which in this case it is time. Okay, and this 10 and this seconds, we have two more things. We have two things on the right hand side. So this 10 is the numerical value. Okay, like kind of, you can again say it's like the magnitude, and the seconds is like numerical value. You can say how much it is. Okay, not exactly magnitude, because if you are clear with vectors in anything, you will get confused. So you can like forget whatever I said. It's a numerical value that like again, not exactly magnitude, but you can say like the amount. Okay, like the total quantified version of it. So like the amount, you can say. Okay, and what is seconds? It is the unit. Okay, like we can say any process like takes t2 is equals to 15 hours. Okay, let's say a process takes 15 hours. So again, this is the numerical value that signifies the amount. Okay, and this is the unit. Here the unit is different because yes, unit of time is seconds as well. Sometimes you can use hours for the unit of time as well, not the standard unit, please don't get confused. Okay, but yeah, this also follows this format only. So that, like, the thing I wanted you to understand is what is a physical quantity is. Okay, what a physical quantity is, which satisfies this definition. And if a quantity is a physical quantity, then we can write q as nu. Okay, and I explained what n is, I explained what u is, and I gave two examples as well. So yeah.
Lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.